Now we're going to be talking about the centroid. The centroid is the intersection of three medians. So what exactly is a median? If we were to take the midpoint of all of our segments, so AC, BC, and AB, I can create D, E, and F. So what I'm going to do is I'm going to connect my vertices to my midpoints that are opposite. So A gets connected to D, E gets connected to B, and F gets connected to C. Notice that none of these are not perpendicular bisectors, nor are they angle bisectors. So these do not split my angles in half evenly, and they also don't intersect my line at a 90-degree angle. However, they do go through my angle. They go through my vertices and my triangles, and they also do go through the midpoint. So this is called a median. A median goes through a vertice and the opposite midpoint. So let me label all of these. Now, what is special about the centroid? The centroid is kind of like the center of mass of the shape, and what it does is we have this really pretty ratio, which is a 1:3 ratio, or 1:2 ratio. What do I mean by that? If I create a midpoint between X and C, what we're going to see is that we actually have the same distance between X and F, and X and this midpoint, and also this midpoint and C. Why don't I just label that midpoint as S. So Fx, XS, and SC are all going to be the same distance. So my point X is going to split this into a 1:2 ratio. So the ratio between distance Fx and distance XC is going to be 1:2. This is going to be true of all of my medians. So if I look over here and I split my AX in half and my XB in half and label them both, then the distance between AT, TX, and XD is going to be equal. And the distance between BU, UX, and XE are also going to be equal. So essentially now we have a couple of 1:2 ratios. The ratio between Fx and Xc is 1:2. The ratio between XD and AX is 1:2, and the ratio between XE and BX is 1:2. If I look at the ratio between any of them in the whole segment, it would be like Fx is 1, XC is 2, and FC is 3.